I will explain you what to do, of course, and I will also help you in trying with the intermediate values of the different different steps of the program. That will help you to cross-check your results too. But it is something that you have to do it yourself, right? Okay. So first, let us talk about the problem. I ask everyone to please note it down, or let me share the screen and I can scribble it here. So essentially, you are having a water at 45 degrees centigrade, right? So you are having, okay. So I hope that is my pen code. So basically, how do I remove this stuff? Good. Okay, so this cooling water is at 45 degrees centigrade and it should be cooled to 30 degrees, right? So there is a 10-degree drop in the temperature of the cooling water. The air at the inlet, which is what we know, has a this dry bulb temperature of 31 degrees centigrade and wet bulb temperature of 22 degrees centigrade, right? So if I try to draw the schematic here and try to write down the different information that is, sorry, I draw a straight line. Right. So the cooling water that enters is at 45 degrees centigrade and it leaves as 30 degrees centigrade. Right. The air which comes in has a temperature of 31 degrees centigrade and wet bulb temperature of 22 degrees centigrade. The information at the exit is not provided, and that is something you have to find it out. Okay. Now, so this is T of air. Now, what other information is provided? Of course, the mass flow rate of water is provided, so that I will write liquid flow rate of water, and that is given as in the problem. Okay, so yes, that is 6,000. So the mass flow rate of water is given as 6,000 kg per meters per hour. So already, to simplify our lives, the tower diameter based on the tower diameter, etc., is given in per unit cross section area per time. Okay, that is how the liquid flow rate is given to you. The gas flow rate is of course not mentioned, and it is said that the gas flow rate GS is 1.4 times of the GS minimum. Right, it is 40% higher than the minimum value. About the mass transfer and the heat transfer coefficient. So KYA value is given as 6,000, right, kg per meter cube hour. And the value of HL, the heat transfer coefficient on the liquid side, is given as a function of the gas flow rate and the liquid flow rate. And this is in kcal per meter cube hour Kelvin. Okay, so these are the informations that is provided. Of course, here GS is the flow rate of the air and L is the flow rate of the water. I mean, that goes without saying. So what you have to find out? So you have to find out, the first step is the air flow rate in the problem. and the second is of course the height of the tower. So if you recall in the last class, we told you that how to proceed with this problem. The first step is to generate the equilibrium curve. Now, what is the, I mean, how can you generate the equilibrium curve? It is this curve. So you are supposed to make a plot of the enthalpy versus temperature. Say something like this, right? So H is the enthalpy versus temperature, right? It can be in centigrade, Kelvin, whatever. Now here you are supposed to draw your equilibrium or the saturation curve. Now, how do you get this information to draw this curve? There are two ways. Either from the psychometric chart, you get that curve of the enthalpy for the saturated air, or you can use the formula, right? You already know the formula for the enthalpy. That is H prime is equal to 2500, isn't it? Multiplied with delta T. So either you use this formula or you get the information from the psychometric chart. Is this clear to everyone? And this enthalpy you will get in terms of kilojoule per. So this formula is for joule. So whatever, either in kilojoule per kg dry air or joules per kg dry air. So here please note that this formula is in terms of, no, this is in terms of kilojoule per kg. Yes, this is in terms of kilojoule per kg. Right, so either you use this formula to generate this curve, or from a psychometric chart you get your corresponding values and then redraw this plot. These are the two ways. And this is the saturation enthalpy. So this is for 100% saturation. So which means that these would be the saturation values. And how do you get the saturation value? So you have to choose some temperature. Let us say this problem is given that has a working range of the temperature is from 30 almost this is the water temperature 45 to 30, right? So within this range most likely your entire operation will be done. So you can easily draw these plots from 20 to, let us say, how much, 50 or something. Right? So you can, if you draw the equilibrium curve in between this region, then it should be fine. So what you have to do is that you have to first tabulate the different values. What is the corresponding YS value? And from this formula, what is the corresponding saturation enthalpy value? So take some discrete point, 20, 25, 30, like this, you can get these values. Write down the corresponding Y star, Y this saturation enthalpy values from the psychometric chart. You can easily find that out, and then the corresponding enthalpy values that you get. Can I quickly ask everyone to get this chart done in your copy or in your graph sheet? So this is how you can construct the enthalpy or the saturated enthalpy or the equilibrium curve here. As I said, the alternative way is also to look into the psychometric chart and note down the HS values. Both ways are possible. In the psychometric chart, you have this curve for 100% saturation corresponding to the enthalpy. So from there also you can, just note down these values. Or you can calculate it using this formula. So I will help you in tabulating these values. right? So based on these values, you can draw the saturation curve or the equilibrium curve. So I want to fix my point 1 and point 2 in this diagram. So what is this point 1? So the bottom side of the cooling tower is generally referred to as point 1 and the top side is referred to as point 2. So at the bottom side, I need to locate the point corresponding to 30 degrees centigrade and enthalpy of the air. So please note, when we make and when we try to draw this operating line, the temperatures are corresponding to the water temperature, right? But the enthalpy is corresponding to the air enthalpy. So please do not mix it up. So at the what the information we know, that the temperatures at the point 1 and point 2 are known to us, right? So this is how I can fix point 1 and point 2. Sorry. So something like this. So this is at 45 degrees. But since we do not know the enthalpy values of the top or the exit air, we cannot fix the point. But here, how do we fix the point? Is because we can find out the enthalpy of the inlet air. How? Based on this information provided that the inlet air, right? The inlet air has a dry bulb temperature of 31 and wet bulb temperature of 22. So using this information, you can locate your point in the psychometric chart, isn't it? And you can calculate all the other properties. This is something we have already done in a couple of classes before. You can get its relative humidity, you can get its saturation humidity, you can also find out saturated humid volume, enthalpy, everything can be found out. So can any one of you tell me what should be the enthalpy values of the inlet air? And that will help us in fixing this point. Anyone? Abhishek? Bhavna?
Yes, sir. Just a second. I'll look and tell.
Has all of you drawn the equilibrium curve? So once you are able to find out the enthalpy
So like
values of the inlet
should
air,
we draw this equilibrium curve manually, or can we use, this is not available on the psychometric chart. So
it
we
is
should plot.
there. It is there, Vardhan. You have to focus more on the course. It is there. Okay, everything we cannot tell you. It is there in the psychometric chart. So either you can use the psychometric chart and go ahead with treating that as your worksheet, or you can draw it separately. And I told you how to draw it separately.
Okay.
So in the psychometric chart, the curve corresponding to the saturated enthalpy line, that is the equilibrium curve in this problem.
ASF found at H dash saturated. Yeah.
Yes. So either from corresponding to that, curve, you can note down the values and redraw it yourself in a graph sheet, or you can also calculate it by, noting down different temperatures, corresponding humidity values, and then from this formula you can calculate the saturation enthalpy and then draw this curve yourself. Or you can, in the psychometric chart itself, you can try to use that to your advantage, but there are several other curves there, so it will be very messy actually to work there.
Sir, I have a doubt, like what this point 1 represents.
Yeah, so you're not listening then.
Sir,
So
I
please
was
pay
trying to
attention.
figure out the points, H dash values. I was trying to figure
Yeah,
out.
so see, the point 1, as I said, the point 1 represents the bottom of the tower, point 2 represents the top of the tower. Now at the bottom of the tower, you have water exit and air inlet. Okay, so in this chart, enthalpy versus temperature chart, the temperature corresponds to the temperature of the water stream. Please do not, get confused. The temperature here represents the temperature of the water stream. The enthalpy here represents the enthalpy of the air stream, not the water stream. And the x-axis are the temperature of the water stream, not the air stream. Okay, so now when I try to mark point 1, what does it mean? It means the temperature of the water at the exit, that is the bottom condition, and enthalpy of the air at the inlet, which is also at the bottom condition. So that represents point 1. Now in the problem, it is already mentioned that the exit water temperature is 30 degree and the inlet water temperature, which is from the top, that is 45 degree. So based on that, I have drawn two lines, 35 corresponding to 35 and corresponding to 45. Now to locate a point, I also need the y-axis information, isn't it? Now for point 1, the enthalpy information corresponding to the air is at the entry condition or at the inlet condition. Now we have to find the enthalpy of the air at the inlet. How you can find out? These two information are provided, the dry bulb and the wet bulb. Based on that, you use your psychometric chart and get the enthalpy values.
Sir, at the inlet, is it like close to 10 kilojoule per kg of dry air?
At the inlet? Yeah, sure.
Sir, I was saying like at the inlet, is the enthalpy close to 10 kilojoule per kg of dry air?
Are you sure? No. How do you find out?
Sir, I took the wet bulb and the dry bulb temperature, and where the wet bulb, like I extended it along the y-axis from wet bulb temperature, and where it meets the saturation curve. At that point, we can find what the absolute humidity is. So
Okay.
taking those 2 points, like the absolute humidity point and the dry bulb temperature point, I found out what would be the value of H.
How come absolute humidity is playing a role?
So because
So you want to
I thought
calculate the
that,
percent humidity.
sorry sir, can you repeat please?
So I am saying why do you need the information of the saturation humidity value to calculate the percent humidity?
Yes sir, like to at least like relate the wet bulb and dry bulb temperature, I thought that absolute humidity should be the point where they meet, like.
No, okay, but so you located the point in the psychometric chart, right?
Yes sir.
And then how did you calculate the enthalpy after that? Please explain.
So after that, I think, after that I followed the adiabatic saturation curve till 100% humidity.
Then,
And then at that point, whatever was the value of enthalpy
so that is
that was
saturation
having.
enthalpy. We are not interested in saturation enthalpy.
Excuse me, sir.
Hmm.
Sir, is the value close to 75.2 kilojoule per kg?
No. How did you find out? Come on,
Sir,
guys. This
the,
is this should be a cakewalk to find the enthalpy values. I think we have solved several problems to find the enthalpy.
Sir, I
Yeah,
first
Trija,
found
how did you find out? What you are doing, trying to
of
do?
the enthalpy of dry air and the enthalpy of saturated air corresponding to 31 degrees centigrade. And then I found out that the relative humidity was around 60% from the given dBT and WBT. And then I interpolated to find the enthalpy.
So that is relative humidity or percent humidity?
So percent relative humidity.
Why are you saying again relative then? Because if you do with the relative, it will get you wrong. You have to do it with the percent humidity if you want to do it by that sort of interpolation. Then it should be the percent humidity, not the relative humidity. Relative percent also is not acceptable. Because you know, relative humidity talks about ratio of partial pressures.
Yes, sir.
So you want the ratio of the humidity values.
Okay, sir. So I'll have to convert the percent RH to percentage humidity.
Yes. Or the easiest way, what is the easiest way? Easiest way is that you locate that point on the psychometric chart corresponding to 31 degree centigrade and 22-degree wet bulb temperature. That point, I think all of you can locate by now, and read the humidity value at that point, right? And once you know the humidity value, you just use this formula. That will give you the enthalpy straight away. This is the easiest way. Shwam, is it understood?
Yes, sir. Yes, sir.
Now calculate and tell me. First tell me what is the humidity value corresponding to this.
So it is close to 50%, like relative
Forget
humidity.
percent, tell me absolute value.
Absolute value is close to 0.015.
1.5 or 1.3? I'm getting 1.3.
Yes, sir, like my it's close. It's between 0.010
That's the reason why
and
I told
1.
you to have the, you know, this psychometric chart as a sheet. If you read from the screen, it will not help you.
So yeah, I'm getting it as 0.015 because my markers are thick, like on the paint app itself. So, but it might be
That's what I'm
0.01.
saying. No, these things has to be done in a pen and paper. We have to get rid of this screen activity now. You have to simply old style. You have to get this thing printed on a sheet, use a ruler and mark that point and calculate it accurately. Now, can anyone tell me what is the enthalpy value? Yash, are you there?
Yes, sir.
So what is the enthalpy value?
Sir, I'm still trying. Like
Just
I
turn
got.
on your camera.
Yes, sir. Sir, am I visible?
Yes. So what are you doing? Show me.
Sir, I'm using the chat.
So why it is taking so long? This should, I mean, this should be done within 30 seconds.
Sir,
Rohit?
actually, I forgot
So
to
keep your camera
calculate that.
turned on. Keep your camera turned on. Rohit, are you there? Rohit is not here.
Sir, excuse me.
Anik,
it
are
is,
you there?
sir, it is showing some internet problems for me if I'm turning my camera on. So
Everything is
can
fine.
I,
We can see you and hear you. So do not worry about those things.
sir,
Focus on the problem. Anik, are you there?
Yes, yes, I'm here.
Please turn on your camera.
Sir, my camera is not working.
Why?
Sir, I have not updated the drives.
So where are you? In the campus or at home?
Sir, at home, sir.
So what is the value of the enthalpy?
So I'm calculating, sir.
How long it will take?
So I'm doing it, sir, now.
Shashank?
Yes, sir.
Please turn on your camera. Tell me what you got.
I'm calculating it.
Huh? What is the value of the enthalpy you got? Keep your camera turned on. Vivek. Vivek, are you there? So Vivek is not here. Good. Abhishek? Abhishek Kumar.
Yes, sir.
Turn on your camera and tell me what you got.
Sir, still calculating, sir.
How long it will take? Come on, guys.
Like previous class, I was not present due to some pieces
So
of
this
light.
is something I told almost a month back on how to calculate enthalpies. I think possibly in the second class or something.
Yeah, I'm forgetting.
Then we solved several example problems. And also these things are recorded. So if you're not in the class, then you should, I mean, go through the
Yes, sir.
recording.
Not getting.
So you
Yes,
cannot
sir.
have that as an excuse that you are absent. Vishal, are you there? Joy, are you there? Joy Dutonde. So Joy is also not here. So whoever is not responding, I will just remove them from the meeting. What's the point of you? I mean, if you do not participate or interact. Then Rakesh. Rakesh, can you hear me? Rakesh. So Rakesh is also not here. Vivek, are you there? Can you hear me? Vivek is also not here. Okay. Sanskar?
Yes, sir. The approximate value is 65.2 kilojoule per kg.
Okay, how did you calculate?
From the absolute humidity value, we can put it into the formula 2500 yi dash plus brackets 1.005 plus 1.88 times yi dash. From that formula, we can put it in we can put it into that formula and we can get the enthalpy value.
And what is the y1 prime?
0.014 is what I've taken.
Okay. Okay. Yeah. So this shouldn't take more than 30 seconds, like half a minute. So H prime, let us write it. It should be in between 64 to 65 kilojoule. What is the unit?
Kilojoule per kg.
Kg of what?
Of dry of air of air.
Of air or dry air?
Moisture.
Not dry air, not moisture.
It is dry air.
Okay, so now I think all of you got this, that the value of the enthalpy is 64 to 65. Let me share the screen. Now, Shashank, please don't turn off your camera. I want it to be on all times. So this is what we get as the value of the enthalpy. So once you know the value of the air enthalpy at the bottom condition, which is the inlet of the air, now you can fix this point 1. Right? So this will help you to locate your point 1. Now after locating point 1, what is the next step? Shoham, what is the next step?
Sir, H will be the same for point 2, so we can find.
H will be same. Why? Come on, what's happened to you? Why
Sir,
H will be same?
Sir, I'll think for a minute. Sorry.
So what should be the next step? Vardhan?
Sir, before that, I am getting the 0.1 above that curve. 64 and 30 on the psychometric.
Possible, because that is this curve, this equilibrium curve is corresponding to 100% saturation. So you cannot have a ER stream which is above 100% saturation. I mean, the enthalpy values cannot be more than its saturated enthalpy value. So you note down, see, that's the reason why you note down the tabulated values. So at 30 degree, this equilibrium curve has a value of 100. Right, whereas for this case where the air is partially saturated, the value is 64 or 65. So that is much below this curve.
Yes, sir, I was marking at 20. Got it, sir. It is below the curve.
See, you should use it in a pen and paper. Forget the screen habit now. I think this is something I told you several times. Please turn on your camera. Keep it turned on. So now show me point 1 in this chart. Turn off that blurring effect, guys. Now show me. Press the apply button. Okay. Now keep the camera turned on. Make a vertical line at 45 degrees centigrade. So on that line, there will be 0.2, right? But we don't know where is that 0.2 and how do we find out? How can we find out what should be 0.2? Anyone? In the last class, we discussed about the guidelines. So after you fix, yes.
We draw a tangent to at point 1 to equilibrium.
So from point 1, we try to draw a tangent to this equilibrium curve, right? Something like this. Sorry. Still not good. I will try to draw it better. More attempt. It's much bad. So once you draw the tangent, the next step is to take help of the this thing. Try to calculate the slope. Right, from that slope you will get the idea of the this GS minimum. So this slope of this line is LCWL by GS minimum. So L is something you know. CW is 4.2 for water in SI units. We have to find out what is the GS minimum. So can I ask everyone to calculate the slope and then find the GS minimum? And tell me what is the value of the GS minimum here in this case. Please note that the unit of the GS minimum will be kg per meter square hour, right? Because L is in kg per meter square hour. L is 6,000. Right? So first calculate the slope and then calculate out what is GS minimum. Vardhan, please turn on your camera. I know you are here.
Yes, sir, I'm.
Turn on your camera. No excuses. And keep it turned on. Tell me what is the value of GS minimum.
Yes, sir, calculate.
Quick. Anyone who is able to get the GS minimum? Shashank? First get the slope,
Yes,
guys, and then calculate GS minimum.
sir, is it 3206.86?
No. What is the slope you got?
7.933.
No. That is far away from what it should be.
So like we have 2 points, that is the point 1 and then okay, the tangent. Yes, yes, sir, my mistake.
Tell me what is the slope. Adrija, what is the slope you got?
So is it 11.2?
11.2. No, it should be around 10.5, 10.6 like that.
Okay,
Anyway, but still that is close at least. So the slope is around in between 10 to 11 or 10 to 10.5 or 10.5, 10.6 like that. Anyway, so what is the GS minimum you are getting? The GS minimum should be in between 2300 to 2400. That is something you are supposed to get. Now you know once you calculate your GS minimum, the next is to calculate your GS, which is 1.4 times of GS minimum. Right? So once you get your new GS, you have to get a new slope and draw a new line, and this is known as the operating line. And this line you only extend it up to 45 degrees centigrade.
Sir, won't the tangent pass through the point 183,40? And then I'm still getting the slope 8 point.
Then you are taking the wrong curve as the equilibrium curve.
No, sir, I am taking the correct one only, the enthalpy of saturated air.
So then I think I think others will confirm you. Anybody else? Shoham, what is the slope you got? Siddhant, Shashank, please say your
getting
slope.
around 9.5.
Sir, I'm getting around 12, like 11.8 I'm getting.
Yes, sir. I am also getting 9.5.
Okay, how come one group is getting 9.5, another group is getting 11.5? So you have to resolve this. And the actual thing is around 10.5. Or 10.6 maybe. I think the location of point 1 is also very vital, where you are locating your point 1. Right? If somebody is getting a different value of the enthalpy for point 1, then your starting location will be different, and accordingly the slopes will be different. I mean, this is only I can think of my head. Okay, so guys, so once you know your this enthalpy thing, sorry, this slope, whatever is the value, I think all of you can now figure out what should be the slope. It's only the accuracy that is making this small difference. And from there, you can work out what is GS minimum. So GS minimum will come around 2300 to 2400, right? And if you do the, I mean, as the problem suggests, it is 40% higher. The actual flow rate is 40% higher than GS minimum. You can work out what is the actual GS value, and accordingly, you can draw a new, this line which is known as the operating line. So let me draw that line. And this line you only draw it up to 45 degrees centigrade, right? So using this new line, which has a slope of 1.4 times less than the slope of this tangent, you can fix your new line, and it will be at the point location corresponding to 45 degrees water temperature. So this will help you to locate your point number 2. Is this clear, guys? So from here you can locate your point number 2. Now, once you locate your point number 2, right, first part of the problem is solved, that you will have to find out what is the flow rate of the GS, or the gas flow that is in the problem. Now what to do? Now you have to calculate your HTG and NTG. Right, these things you have to calculate, because the final height is the multiplication of NTG cross HTG, isn't it? And to calculate your NTG is nothing but this integration of dH by HI prime minus H, isn't it? This is what your NTG is. So to calculate that, you have to take help of the tie lines, right? So you construct as many number of tie lines as possible, like this, right? Now these slope of the tie lines, how can you construct? These are parallel lines, right? So this slope of the tie lines is something which you already know, that is HL by KY. Right? This is the slope of the tie lines. So you know how to calculate out your HL, and KY already is given 6000. So can anyone tell me what is the slope of these tie lines? Quickly. So guys, please note in the problem I have said that the value of HL is a function of the liquid flow rate and the gas flow rate.
27.9.
Huh?
Considering like GS as 33600.
So GS is how much? 33?
600. I mean, we have like as you said, GS minimum to take us 24,000.
Okay. So how much you are getting? So how much you are
27.
getting your HL?
Like I've just calculated the total. Just a minute, sir. HL will be
Tell me what is the value of HL? HL.
167512.9654.
What?
0.059 into 6000 power 0.51
Please say again. What is the
0.
value of HL?
0.05.
The value of HLA.
167512.
75?
12.97.
So that is like 167512.
3. Yes, sir.
What is the unit?
I think the GSE you have taken has 1 0 extra. I
Yes, it is
Yes, sir, it's 16751.2.
Yes, 0.2.
This is the unit, Vardhan.
The unit will be kilocal per meter cube H. Kg per meter cube H, sorry.
Kg. HL is in kg. HL is in not in kg, guys. KY is in kg. Now this you have to convert into SI units. Kilocal to kilojoules. So what is the conversion? Shashank, you are an engineer now. Almost. You don't need Google to find out the conversion of kilocalories to kilojoules.
4.2.
So do it and then tell me.
So 4.184.
Hmm?
4.184.
I don't need the conversion. Tell me the value of in kilojoules.
Around 70K.
78.
70K. 70,000.
Now work out the slope of the tie lines.
Uh, 11.67.
Something like this, minus 11.5.
Yes, sir.
Right. So with this slope, please construct these tie lines. Okay, you can take as many tie lines as you want to draw. That's up to you. So what is the next step? The next step is that based on these different tie lines, you have to calculate out what is the, so for each tie line, you are supposed to calculate out what is the enthalpy value on the operating line and what is the corresponding enthalpy values on the equilibrium curve. And you can take the difference of these, enthalpies, if possible at equal intervals. If not, at least the temperature difference should be at equal intervals. This is the reason, if you remember in the last classes or in the couple of class back, I talked about the alternative form of the NTG. Right? You can also do it in terms of the temperature difference, not, I mean, in terms of the temperature instead of DH. Why? Is because, I will tell you the reason, is that here when you are trying to, so what you will list down, so let us just work it out. So you will have the different water temperatures in the tie lines. What are the values that you will list down? You will list down the H values, right? You will list down the HI values. You will do HI minus H, this quantity, and then you will have 1 by H I prime minus H, right? So then to calculate this NTG, what you have is this is from H1 prime to H2 prime, and you have to do it. This is the form, right? So let us say you choose different temperatures starting from 30 to 45 degrees centigrade of the water temperature. You can choose 35 every 5-degree interval. That is easy to choose. So, or you can choose, let us say, why 5 degrees? 2 degrees you choose. 32, 34, 36, like that you can choose. And you correspondingly write down the enthalpy value. So the enthalpy values are 30 degrees around, let us say, 64. And you write down the intermediate enthalpy values. This would be around 180. Okay. Now, if you note here that the enthalpy differences will not be uniform across two temperatures. Please understand, guys. This enthalpy difference will not be will not be same. So ultimately, to do this numerical integration following trapezoidal or sinusoidal rules, it requires you to have constant intervals of the independent variable. Isn't it? What you are going to integrate? So this will be your x and this will be your f of x. Isn't it? If I choose this to be x and this will be f of x. Right? So you are making an integration of this quantity. So for this integration, I mean numerical integration to happen either by Simpson's rule or by trapezoidal rule, you need to select constant differences, right? Or these values of the x or the enthalpy values. But that is difficult to set. Right, you can only select constant differences of the temperature, but not the enthalpies. I mean, you can, enthalpy can also be done in the same way, but that may be very difficult to set. The easier option could be to set the different temperatures. Alternatively, if you still want to stick to constant enthalpy, then you have to select from the left hand side here, equal intervals of the enthalpies, and correspondingly those points on the equilibrium curve first has to be noted down, and then you try to draw down, then you try to not on the equilibrium curve, on the operating line, you select constant differences of the enthalpy, then you mark those points, then you draw tie lines and get the corresponding equilibrium enthalpy values. Equilibrium enthalpy values are HI. Right? That is one way, or else the easier option is to take constant differences in the temperature. So you discretize in the x-axis with constant intervals. Right? So if you do constant intervals of temperature, then it is better to use the temperature relation of NTG instead of the enthalpy relation. Right? So this is the temperature relation you have. Here in that case, it would be temperature from 30 to 45. So this is the alternative version of the NTG. So either ways, whichever is convenient for you, you construct these with the help of the tie lines and get your NTG. Is this clear to everyone?
Yes, sir.
Is there anything which is not clear or is not understood here? Please let me know. And the formula for, what is the formula for the GST? So this is from H1 to H2. Formula for HTG is GS by KYA. Okay, so if you multiply these two, you should get your Z, and the calculation for the Z. So NTG values, I can tell you what is the HTG and the NTG values that you are supposed to get. So the the NTG value that you will be getting is in between 6.5 to 7 in this range, and HTG value is 0.4 to 0.5. Or maybe 0.6 you can think of, because many got GS very different, right? And that is straightforward. So accordingly, the height of the tower will be in between 4 to 5 meters. So this is something you have to work it out yourself. The integration is a very important part, and you should do one exercise yourself to get conversant with the technique. And whether you want to use this L alternative form with the temperature, or do you want to use the the enthalpy integration is dependent on you. So if you want to use the alternative form, that is the temperature thing, then the HTG expression will be slightly different, right? It will be in terms of LCYL KYA instead of GSKYA if you want to use the temperature based NTG form. I hope this is clear to everyone. Anyone has any clarifications needed? Any confusion? Please say it now, because today is the last class for this topic. On the next day, we will start a new topic. Okay, one more announcement I should make is that whenever this first test we will be having on this course, we will have this on the part related to the humidification and cooling tower. Whatever the next topic we start, that we will not include in the first test. So this is just I'm reminding you in case I forgot to say this. Okay, guys, so we stop here for today. I strongly encourage you to please go through this problem. This is also a solved example problem from the book by B.K. Datto. So you can also go through it if any one of you could not follow any of the steps here in this class. Okay. So thank you all. We will meet again in the next class.
Thank you, sir.